Okay, welcome everybody. My name is Robert Cluett, and I'm with a company by the name of Cyber Defense Contractors. We can be reached at 978-283-3894. You may also reach us at the email address of security@cyberdefensecontractors.com. Just a brief overview of my history in the information technology industry. I've been in the industry for 27 years. I spent 15 of those years working for a Fortune 20 telecom. I spent more than 12 in a routing and switching role, more than 10 with a combination of Linux and as a full stack developer. I spent 4 years with a hands-on role in the content delivery network, in 4, maybe 5 years now in the cybersecurity role. I own and manage Cyber Defense Contractors. All right, so this is a technology workshop. What we like to do from time to time is focus on a specific technology and do a bit of a deep dive to get into the inner workings of it. And we do this to give meaning to our other workshops we hold that discuss the security and privacy aspects of this specific technology. So while we might not get into too much detail about security and privacy as it relates to a CDN now, down the road, that is something we may do. We also like to educate by leveraging our own experience, and it's a means of industry participation, a way for cyber defense contractors to give back to the technology community in much the manner that has been done for us throughout the years. So that's something we like to do. So today we're going to be talking about a CDN, or a content delivery network, and the presentation itself is based on Cisco's flavor of a CDN. The reason why it is focused on Cisco's flavor is because that is the CDN that I built, I managed, and I configured, and I did the troubleshooting for. There's going to be various types of CDNs would be out there in the technology industry, and they're all going to be different. Some are going to be homegrown Linux solutions. Actually, probably a majority are homegrown Linux solutions. Cisco's actually is a bit of a Linux solution because underneath the CDN operating system is a Linux operating system. They did buy that product from another company, although I don't remember the name of the company they bought the product from. I can tell you the name of the company that they sold it to, and that is a company by the name of Permia. And they sold it to them in 2018, and it was rebranded from what was VDSIS, or Cisco Videoscape. VDSIS stands for Video Distribution Suite, Internet Streamer, and it's been rebranded to a product called Cinemedia. So this CDN provides what's been coined over-the-top, or OTT. All that really means is you're distributing video over a IP network. Whether it's IPv4 or IPv6 does not matter. It's an IP network, and it's a bit different than the linear TV that we're typically used to with cable or satellite TV providers. Although most cable and satellite TV providers have modified their model, and they're now delivering over IP-based networks over the top. So this can be deployed in the enterprise or on the internet. So that would be either the internet or the internet. So now that we have that out of the way, let's talk about one of the main drivers of obtaining and implementing a CDN, and that would be latency. For those who are in the industry, who are keenly familiar with the term, we understand that latency is one of the cruxes, so to speak, of network design and network troubleshooting. So let's take a quick look, and you'll notice up on the upper left I have 4 milliseconds. That might be a typical latency for a network that is specifically just a LAN, a local area network. That's even a little bit high. for a LAN, or it may be a highly congested, a high bandwidth WAN that would deliver that type of low latency type of speed. So 4 milliseconds to 10 milliseconds is another one you might see. Again, that's fairly fast. That's fairly good and fairly low latency. When you're getting up to 100 and 170 milliseconds, you're getting into an area where your latency is starting to get a little bit high, and that's something you'd probably want to take focus of or take a look at. And 200 and 300 milliseconds, again, you're very high there, and you want to take a look at ways at solving that problem. And CDN, once again, is one way to do that. And we'll get into that a little bit later. All right, we have a picture of the globe, and over on the left, we have a user, and he is in Boston. And over on the right, we have a server that is located in Chennai, India. So it is all the way across the globe, so to speak, and you would expect low latency. There would be a transcontinental link in between these 2 points, and that would be a high bandwidth link. But with the amount of traffic that typically flows over links like that, you're going to get high latency. You're going to get slow response. So let's look at what happens. And a user, let's take a step back. That did not display how I wanted it to display. Let's try one more time. Okay, so the user accesses the web server in Chennai, and if you look to the right, you'll notice the slow response and how slow that web page renders. This is a good example of kind of what's happening underneath the covers here. Your slow response, you're not going to see a web page render like that. You're going to see artifacts or elements render one at a time, or in conjunction with one another. But they're certainly not going to render a page rolling up from the bottom to the top. But it is a good way to display the slow rendering that takes place with a typical 300 millisecond latency, or a server that's located across the globe. And that's the problem that we want to solve, and that's the problem that a CDN targets to solve. Okay, what we've done is we've placed a CDN node over in Quebec, and we're going to distribute content that is related to that web page. There's going to be images, there's going to be JavaScript, there's going to be video, there's going to be HTML, there's going to be CSS or cascading style sheets. So all of that stuff is distributed beforehand over to another server over in Quebec. So it's really an extension of this web server. And let's see what happens when that user attempts to see that page and gets it locally or closer to the user with a 40 millisecond response time. You saw how quickly that page rendered. Let's take a step back. That's a step forward. That's not where I want to go. And there it is. We saw it again. It rendered very quickly. So in that short amount of time, we have described to you exactly what the use of a CDN would do and why enterprises and large companies, or even smaller companies, seek out CDNs to complement their web server farms and to provide better user experience and customer service to their online users. All right, here again is another picture of the globe, and we have the kind of the same scheme here. We have users in the yellow or gold color, and we also have some CDN nodes distributed across the globe in the green, and we have our target server still in Chennai. And let's take a quick look at what happens here. You also notice we have that transcontinental link. Okay, so you see the distribution taking place and it's distributing content. It's distributing it in a tiered architecture from your origin server to your layer 1 nodes and then to your layer 2 nodes in your CDN, are really not called nodes. You might refer to them that way, but they're often referred to as surrogates. Cisco calls them streamers, but the industry-wide adopted terminology for this is a surrogate. So it's kind of a so you can see how it's kind of a layered architecture. You have a tier 1, a tier 2, and a tier 3. Typically, you're not going to go beyond a tier 3. That's typical design philosophy behind CDNs. You want to keep it to as minimum tiers as you possibly can. And there's the users acquiring that content. And these users are located in close proximity, geographically located very close to these CDN nodes or the surrogates. So you're noticing that the latency time for these users has dropped considerably in each one of these spots, 40 milliseconds over there in Boston, and at the various other points throughout the globe, you're having 35 milliseconds, 51 milliseconds. So you're really creating faster, higher quality, better user experience for the user. Now, if you look down to the lower right, you notice that I've coined this live streaming or primed. Live streaming is just like it sounds. You're delivering live video broadcasting. In this case, it's unicast. It's not technically broadcasting, but it's a term used in two different scenarios and had two different meanings, really. And the reason why I call it primed is because that stream is being generated beforehand, before any user requests it. So it's already sitting at those CDN surrogate nodes, and it's waiting for a user to request that data or that video stream. Okay, so why CDN? We've already answered that question, at least partly. It makes your website and your video streaming service very fast, relatively speaking to having just a server farm located across the globe. You're going to get much higher response and lower latency. And as I said right here, it creates a situation of low latency content delivery for improved load times and video quality. It also distributes CPU and bandwidth utilization across its surrogates. So it's kind of a mechanism to generate a fault-tolerant, redundant network of video streaming surrogates. And there's certain mechanisms built into specific CDNs where it's going to take a response in regard to high CPU utilization or high bandwidth utilization, and it might offload a number of users from one CDN surrogate to another CDN surrogate or set of CDN surrogates. And as we already mentioned, it provides redundancy and high availability of your web delivery service that you're providing to your customers. It increases your global reach. Obviously, that's obvious by the picture that we used with the globe. And it efficiently delivers where multicast cannot. We'll get more into multicast a little bit later, but you really can't have a discussion of CDN's ability to deliver unicast video or web page artifacts in the manner that it does without having a conversation about multicast as well. So again, we'll get into that a little bit later. It strategically and logically controls the flow of unicast data or video streams. It stream quality adapts to congestion, and adaptive bitrate streaming is the term that we'll want to focus on there. And what adaptive bitrate streaming is, we'll get into that a little bit later as well. But that is what allows a low bandwidth link to deliver a high quality video stream. And generally, overall, what we're doing here is we're vastly improving the user experience. So once again, why CDN? We're going to distribute HTML, JavaScript, cascading style sheets, images, and video. We can distribute documents and downloadable files. We can distribute Word documents, Excel documents, PDFs, and we deliver over-the-top video. And like I said before, over-the-top video, that's any video that's laying over the top of an IP network. In most cases, it's going to be an IPv4 network. But I'm sure there's plenty of IPv6 networks that are delivering video, OTT video at this point. It also delivers video on demand, or VOD, and that's just like it sounds. It's just like you're familiar with your local cable provider. Anytime you want to download a movie or a soap opera or whatever the case may be, you might download that as video on demand rather than watching it live. All right, what are some of the causes of latency? Your primary cause is likely to be distance. It could also be congestion. It could be bandwidth, and by bandwidth we mean the limits that are placed upon the network infrastructure by way of design. And data transmission degrading qualities, things like crosstalk, would cause a latency issue, or could cause latency issues. What makes a CDN a CDN? This is kind of a good question, because it really allows me to cover a wide breadth of information here. So it's strategically placed in geodiverse set of proxy servers. It's distributed spatially or geographically. It maintains multiple surrogate servers that host the elements of your website and your video streams, both live and on demand. It maintains two or more servers that route users to the nearest surrogate or server. That's really what a surrogate is. It's just a server, and in most cases it's a Linux server. If it's closer to the user, the latency decreases, and that's one of the biggest benefits of a CDN. It maintains a primary surrogate that ingests and distributes website or streaming video content to the entire CDN. That basically says it all right there. It maintains two or more servers that control initial content acquisition and distribution to its surrogates. It does so in a logical and efficient manner. And I added this in here because I think this is important to take note of. I call it the cloud before the cloud became a marketing term. And why do I do that? Because if you really look at the architecture and design of a content delivery network, where it has a central repository and it distributes from a central repository out to its surrogate nodes, whether they're 1 tier, 2 tier, or 3 tiers away, really kind of has a cloud flavor to it. Has kind of some of the same mechanisms or kind of the same aspects to it that you think of when you think of cloud. And believe it or not, one of the first applications that was moved to the cloud in most environments was a CDN. And you'll note that by, or at least I noted that by some of the articles I read on the internet, some of the blogs and posts that people were posting, some of the experts. So that's just something to keep in mind. Okay, unicast and multicast packet flow. These are, what you're looking at here are really three different addressing schemes. You have unicast, multicast, and broadcast. And network flow or network traffic packet flow is different for each one of these addressing schemes. So the first one we're going to take a look at is unicast. And you'll notice with unicast, you have your, we'll call it a video stream. We have it one stream per user going across the wide area network. Is that a great thing? No, that is not a great thing, because you're increasing the utilization on your WAN. You have 3 video streams across the WAN, your utilization goes up, and you're taxing your wide area network. So this is another aspect of a CDN that we want to incorporate, or another reason why we'd incorporate a CDN in order to solve this problem of high utilization. Let's take a look at multicast really quick. But before we start any video streams from happening, we have to drop in some multicast enabled routers. And what those multicast enabled routers allow you to do is to transmit multicast. Okay, so what would this look like? You have 3 users, 3 of them joined this multicast stream, 1 walked away and went to lunch. So you have 2 streams, and you have, notice you have 1 stream, not 2, crossing the wide area network. And that should be of particular interest to you. What you're doing is you're decreasing the amount of utilization that you're going to have across the WAN substantially. So no matter how many users we had over here on the left that wanted to view this multicast, we would still only send 1 stream across the wide area network. That's a beautiful thing. So 1 video stream across the WAN, your WAN utilization is low, or is dropped. And as we'll see in another picture or another animation, that CDN really mimics the way a multicast network works. And you really can't have a discussion of unicast and multicast without having a discussion of broadcast as well. So let's take a look at how broadcast will work. Looks an awful lot like unicast, and it certainly is. But broadcast really doesn't have a place here for us to really discuss it in any length or in any depth. You really want to focus on the unicast and multicast addressing schemes. Broadcast is something we all know and we're all familiar with. It's one of the first things we learned when we began our journey learning about networks in general. And you'll notice here that I commented that 3 broadcast flows across the WAN and your utilization is going to go up. So the types of content ingest, and again, content ingest is exactly like it sounds. You're ingesting content into the content delivery network or into the CDN. You have preposition or prefetch content ingest. That is anytime you've taken your HTML or your JavaScript or your cascading style sheets or your images or your video, and you've positioned them out to the surrogates at their tier 1, tier 2, or tier 3 nodes. In other words, the content already exists there. It's not waiting for a user to request it. It's just there, and it's there for the user to grab. So no ingest begins when a user does the request. It's already there, and that's really an ideal way to deliver your content for a website, a web page, or a web app. There's also a mechanism by way of URL crawling, and URL crawling is just like web page indexing or the indexing that Google might do. So it goes out and it has a web page that it's going to fetch, and it starts with that web page, and then it looks at all the links inside the web page, all the images, and it starts fetching all this content that's based on that web page that it's crawling. So really, that is a form of prepositioned or prefetched content ingest. So there's some overlap between those two. There's also dynamic content ingest, which would really just be pure caching. Similar to having a dispersed set of varnish nodes. So a CDN in this instance would replace your varnish nodes that you might have fronting your Apache or Nginx servers. So that would be acquired dynamically and as it's requested or as it's needed. The first person to request a piece of content, it'll do a cache fill, and it'll fill that layer, that tier 1, tier 2, or tier 3 surrogate node, and it'll be there for the next person to request without having to go through the entire ingest process again. And then you also have live stream splitting or video broadcasting, which we showed in a prior animation or a prior slide. And I think we're going to show it again. Okay, but what we're going to do is we're going to actually start from the ground up, and we're going to build a CDN. The first thing we have, and the first thing that exists in any CDN, is going to be your origin server. And all origin server means is web server. That's your main web server. That's your server that you're feeding your website from. You might be serving video there as well, but that's where all of your content is going to reside if you didn't have a CDN. And that's directly where, in the kind of the old school days, that's directly where a user would acquire the content or visit a web page or a web app. All right, so we have a user over here on the left, and that user is in Rockport, Massachusetts, with a laptop. And we have another user in Boston, Massachusetts, and he or she has a mobile phone. And they are going to want to traverse this cloud and obtain content from this origin server, which we also have called a web server. They're the same thing. And that server is located across the country and in California. All right, so that cloud goes away because we're going to make sense of that cloud. The first thing we're going to drop in is our CDN management node, and that happens to be in New York in this diagram that I've drawn. What a CDN management node is going to do is going to have complete control over the CDN as a whole and all the different components and pieces and parts. It's going to have one management interface, maybe two management interfaces if you have a command line, and you also have a web GUI. But that is going to be your management node, and that is going to perform a lot of the steering of traffic. It's going to define specific parameters, caching parameters. It's going to define your tiered streaming architecture. Okay, the next thing we drop in is our content acquirer. Our content acquirer is another surrogate node. This is where content would be ingested into the CDN to, not from, but to. And in this case, it's located in Arizona. So we have a CDN management node in New York. We have a content acquirer in Arizona. And in California, we have an origin server or a web server. And we have another surrogate in Texas, another surrogate in Maryland, another surrogate in Massachusetts. Okay, now we also have a service router. And what a service router is it contains what's called a content routing. What it does is content routing, but what it contains is a coverage zone file. And what a coverage zone file is exactly like it sounds. It's a list of networks or user networks that exist out on your network with an associated streamer listed along with it. So when the request comes in to the CDN, it comes into that service router, and that service router, based on the IP address of the user, is going to direct that user to get content from its closest streamer. So in this case, since both of these folks happen to be in Massachusetts, we would hope that would be the Massachusetts node. And we also have our domain name, a routing domain name or DNS server, and we just happen to put that in Delaware. You can't have a discussion of a CDN without having a discussion of DNS, because that is really how all of this routing architecture or this routing takes place. All right, so a user sends a request to a DNS server, and it says, give me the IP address of the live video host at this URI, https://live.null.net/broadcast8. And the DNS is going to respond, and it says, here's the IP of the service router. So we've associated that domain name with our CDN. And the way we did that was through DNS. We said anytime someone is looking for this domain name, we want to send them to this service router and let the service router respond let the service router tell the user where to get their content from. So it's kind of handing off the distribution or the communication aspect of this. It's doing a handoff from DNS over to the service router within the CDN, or the content delivery network. So this user sends a request over to the service router in New Jersey, says the DNS server said that you know where the live feed is. Here's an HTTP GET request. Notice it did an HTTP GET request. And that makes sense, because after you do a DNS request of a web server's domain name, you're going to get back information that will allow you to perform your HTTP request, because that would be the logical next step. Only in this scenario, that HTTP request or HTTPS request is going to our service router. And we'll see that. Okay, and the response of the service router says, based on your IP address, the Massachusetts surrogate is the closest. Here's an HTTP 302 redirect to that server. So it's sending a 302 redirect, which says, I believe a 302 indicates the content is moved. I can't remember if that's permanent or temporary. I believe it's permanently moved, but I can't say for sure. And then that user sends its HTTP GET request to the Massachusetts surrogate URI, and that Massachusetts surrogate is very closely located to Rockport. And then our streaming starts. So this would be a live video broadcast. This would be a cache miss situation, or unprimed. Unprimed meaning we didn't have this stream being delivered throughout the surrogates of the CDN beforehand. It waited until a user requested that stream. Okay, so what problem does a CDN solve? Without an associated multicast infrastructure, you may be limited to a low bitrate video stream, no matter if you have a CDN or not. The constraint is your network. However, a CDN will improve your ability to deliver content. Not all sites will have big pipes. So some of those sites that have DS3s, but have 6,000 to 10,000 users on the other end of that DS3, they're going to need a CDN if they're not a multicast enabled network. Otherwise, there's going to be congestion on that DS3, and only a handful of users will actually be able to get that video stream. Or more than a handful, say 25 users might be able to get it with the typical bandwidth requirements of a video stream. So each user consumes a single stream, which is unicast delivery. Streams add up quickly, and it risks over congestion of the WAN. It puts web page artifacts closer to the consumer for fast delivery or web page rendering. We've seen that in a previous slide. It provides for increased visibility into your content delivery infrastructure. It does that as well. Okay, now what you see at the top is an animation I created to kind of drive home a point. What we have here is a T1. I know I'm dealing with legacy technology when you talk about T1s, but T1 was the big pipe back in the day when I started with my my networking career. So we have ones and zeros crossing this cable, and you notice at the bottom I have a timeline of milliseconds. This is your typical time it would take to deliver those ones and zeros across that pipe. Okay, so we have to think in bits, and anytime we're dealing with a CDN or video delivery, we want to think in bits. So the maximum capacity of this cable is expressed as a data rate, and that data rate is 1.54 megabits per second. The current rate of transfer of these bits is also expressed as a data rate. Okay? So when the maximum capacity is exceeded, packets are dropped, unless you have QoS and ABR. Actually, that's not entirely true. Even if you have QoS, you're going to drop packets, but it just depends on how you have your QoS scheme engineered or architected. But ABR is going to afford you the ability to adapt your stream or modify your stream to a lower bit rate in order to handle more users. Or in other scenarios, you might be able to handle a higher bit rate. And ABR is going to allow you to do that. You don't have one statically defined bit rate for your entire network. In most cases, when you're going to statically define a bit rate, you're statically defining on the lower end to circumvent the issues that you have by not having a CDN or by not having a multicast architecture. Audio and video quality will suffer, and video buffering is likely to happen. That is true, and we've all seen video buffering happen. Multicast and a CDN help alleviate this issue on congested WAN links by sending single streams across the WAN and to multiple consumers. A surrogate can be looked at as a type of repeater. So from high level, you can sort of look at it that way as more of a repeater. So the comparison. All right. A CDN looks and acts very much like multicast. We've seen that. They both distribute it in a similar fashion. They distribute content in a similar fashion. Cisco defines multicast as a bandwidth-conserving technology that reduces traffic because it simultaneously delivers a single stream of information to thousands of corporate recipients and homes. A Unicast CDN does the same thing. And it does this for things like video conferencing, corporate communications, distance learning, software distribution, stock quotes, and the news. The high-level value proposition. So when deployed in the enterprise, when a CDN is deployed in the enterprise, it drastically reduces bandwidth utilization and latency to larger sites. Those are the sites where you might have 6,000 to 10,000 users, big sites. This value add cannot be understated. Saving bandwidth saves money and assures the efficiency of your network. We all know that to be true. A CDN can deliver 2 traditional VPN users with co-located surrogates at the VPN head ends. If you have a CDN, you may not need expensive multicast-enabled routers because they are expensive. When deployed on the internet, you expand your global reach and provide high-quality content. At a very basic level, you alleviate your web hosting infrastructure from the task of content delivery. So you're really creating an extension of your web server, and that's significant. To be able to flip a switch and have content be delivered to this widely huge dispersed server farm is a fantastic thing, to be able to flip that switch. And again, coming back to the discussions of cloud is meant to be flip the switch, do things quickly. So in this case, in this instance, and in this description, this is one way in which you flip a switch and you go from having small means to larger means. Oops. Content routing. Okay. So content routing really is at the center of all of this. And what is content routing? It's the concept of a coverage zone file. And I described what a coverage zone file is in a previous slide. What it is it takes basically your IPAM or your IP addressing application, and it takes those subnets and it lays them out into a XML file or maybe a JSON file, and it associates a surrogate with a subnet. It actually associates at least 2. The reason why it associates 2 is because you can have a primary and a secondary, and that's kind of where I noted that it's a redundant failover surrogate. But we're skipping over a step. So it's intelligent service routing based on geographic location. request routing is what it's called, and you'll find that in RFC, that terminology. That's not Cisco proprietary terminology. So you have redundant failover surrogates, and it provides for a means to load balance. We've already talked about that. It allows for a load-based routing based on CPU or even stream count. It does not work easily with NAT, and no CDN does. Or at least Cisco's version did not work easily with NAT. And we had to come up and engineer some pretty significant and pretty intricate ways of working around NAT as an issue. And you must have an accurate and updated IPAM in order for you to build that content routing file. So who uses CDN? We've got Netflix, Disney Plus, Hulu, Amazon Prime, Twitter, Facebook, Comcast, YouTube. There's a slew of these guys. They're everywhere. CDNs are used by all the big players because they're a necessary component of any network architecture. Who are the CDN providers? We have Verizon through the acquisition of, I believe it was Edgecast. We have Limelight. We have Akamai. Those are probably your three most notable players. I don't know if they're your biggest players, but they're your most notable players. You have Rackspace, Cloudflare, Google, Amazon. Amazon has entered this space with, I believe it's called Cloudflare. No, is it called Cloudflare? No, it's called, I can't remember what it's called, but we'll get to that a little bit later. So we have Amazon Software, Microsoft, Max CDN, StackPath, Fastly, Encapsula, CenturyLink, and CashFly. There's also free CDN providers. One of them is Cloudflare, which I mistakenly associated with Amazon. There's Encapsula, Photon, which is by Jetpack, which is associated with WordPress. We have Swarmify, CloudFront, that's what it's called. It's called AWS CloudFront. So that's your Amazon CDN service. And then you have Google Cloud CDN, you have Microsoft Azure CDN, and you have Cloudinary. Bitrate and data rate. Okay, we talked a little bit about this when I showed you that animation of the ones and zeros going over a 1.54 megabit per second T1 pipe. So bitrate is also a video resolution. You know, how can that be? Well, when we talk about video resolution, we're talking about it in terms of bitrate and how quickly we're disseminating video content, or ones and zeros, these bits, over a wire. So bitrate is related to bandwidth as much as it is to your video resolution. It is the transfer of bits over a time that render video in the browser or player. So something someone might say would be the bitrate of that video is 1.5 megabits per second. And that is a video that would just barely fit over a T1. Okay, bitrate equates to the amount of bandwidth consumed, or the percentage consumed. So someone might say we're at 50% utilization, or 5 gigabits per second of a 10 gigabits per second link. So we've got utilization, bandwidth, bitrate. You're starting to see the connection here between all of this. Bitrate equates to bandwidth relative to overall capacity. So a Cat6 Ethernet cable is capable of 10 gigabits per second. Again, you're starting to see the connection between all of this. So you're talking gigabits per second, megabits per second, kilobits per second. It's bitrate and data rate. Adaptive bitrate streaming, or ABR. Okay. So what happens with adaptive bitrate streaming is you're generating multiple bitrate streams for a single broadcast or video on demand file. So instead of having one stream that's running at, say, 720 kilobits per second, you might have one running at 250 kilobits per second, one at 500, one at 720, and then maybe one at 1.2 megabits per second, and that would be your highest quality of the four streams. So bitrate stream switching happens based on network and endpoint congestion. upscaling. It's called upscaling or downscaling. ABR, adaptive bitrate streaming, happens at the client end, but sometimes happens at the surrogate side. Depends on the CDN. I think it's also going to depend on your player as well. Without ABR, you're forced to run the lowest bitrate that a low bandwidth site can handle without oversubscribing your WAN link. So folks with a big pipe get low quality, just like small sites. ABR and QoS together reduce and limit the bandwidth congesting traffic. This improves user experience, and that is what the target is. So here are your 4 streams, all running at different bit rates. It's the rate at which those bits are going across the wire. You notice 3 megabits per second is happening very fast. 500 kilobits per second is happening relatively slowly. So all 4 of those streams that you see here would be associated with one video, and the user would switch between these depending on congestion on the WAN. If there's high congestion, everybody might be getting a 500 kilobit per second stream. If there's low congestion, everybody might be getting a 3 megabits per second stream, and we're getting close to or approaching high def video. Common adaptive bitrate streaming techniques. Okay, there's really four big players here. I don't think there has been any other large players in the market since I've had my hands on a CDN, but MPEG dash, and the reason why I have that first is because you'll notice it's an ISO standard, and I've watched this with a close eye throughout my time in the industry, watching what MPEG dash does, because I saw it as a solve-all solution, as a solution that was going to resolve all the complexities and issues that we had with streaming and video players. And it looks like it has done a great deal of that. However, Apple has come out with some recent stuff that goes right up against MPEG dash, and offers a good comparison. It might even deliver better quality video over low latency links. Anyways, the 4 players are MPEG dash, Adobe HTTP Dynamic Streaming or HDS, Adobe HTTP Live Streaming (HLS), and we also have Microsoft's Smooth Streaming. And I think I have the players on the next page. Each requires a video player capable of running that protocol. So MPEG dash is going to use something like dash.js. It's a JavaScript library that is intended specifically for the MPEG dash protocol. Your Adobe is going to use your Flash player. Your Apple HTTP Live Streaming or HLS is going to use, there's many players that can run that, but the container that it uses is an MP4. And then your Microsoft Smooth Streaming is going to use Silverlight. Okay, I'm just checking time here to make sure we're under an hour now, and hopefully we can keep this under an hour. So MPEG dash, it's dynamic adaptive streaming over HTTP. It's a sequence of small HTTP-based file segments delivered by an encoder. I don't think we speak too much about what an encoder does. No, actually, I take that back. There is a slide later on. It's actually been a while since I've reviewed this deck, and there is a slide later on that does describe what an encoder is. So MPEG dash, it alternates segments encoded at different bit rates. It's client-driven congestion control, so it's done at the client side rather than at the surrogate side. And your existing HTTP web servers are well suited, Apache and Nginx. It's an ISO standard, and it's the first streaming protocol to be a standard. It's codec agnostic, which is another great benefit. You don't have to deal with all the different various codecs. And it does not directly support HTML5, so you would need another component embedded in your HTML5 web page in order to play an MPEG dash file. So here's some typical resolutions you'll have with MPEG dash. Okay. So you notice you've got 1280 by 720, which is pretty good, but that requires a 1.5 megabits per second bitrate stream. And we've also listed your bits per pixel here as well. 1920 by 1080, I believe that is considered high def. 720p maybe, possibly. And then you got 496, 2160, that is definitely high def. So that's just kind of a layout for MPEG dash and the bit rates that you're going to get relative to resolution and frame rates per second. So CDN, VOD, video on demand, how does that work? Okay, so here we've got our network again, our CDN, and we've got our two users over in Rockport and one in Boston, both in Massachusetts, and they're going to acquire their content from the surrogate in Massachusetts. But if you notice over on the right near the origin server, there's another file. It's called the manifest file. And what that is that's an XML file or JSON, but in the case of Cisco's product, it was an XML file, and that listed all of the content that the site owner wanted distributed throughout the CDN. So each web page artifact would be listed in there. It'd be listed as a video file, might be listed as an image file, or CSS or HTML or JavaScript. So it retrieves and reads the manifest file. The content acquirer retrieves that from the origin server, and it pulls that content from the origin server. So right now it's pulling an MP4 video. Oops, let's jump back. And it's distributing it to its second tier. So it's doing what would be considered a cache fill process. And this user over here on the left wants to watch that new file, so he starts getting the file directly from the surrogate. Now that MP4 file is already there, so no streaming needs to take place on the back end. He's just getting it from there as if it was any old web server. The manifest file. We've got about 7 more minutes left. The manifest file. So it's pre-positioned or prefetched content ingest. It's typically an XML or a JSON document. It lists the content the provider intends to ingest into the CDN. It's associated with a delivery service, and a delivery service is what Cisco calls it. You won't find that in an RFC. And the manager node reads the manifest at intervals of maybe 1 to 30 minutes. It's going to vary depending on which CDN you're using. And it will purge or add content as instructed. One issue that we ran into early on when adopting Cisco's product was the purge was taking place when the manifest file was being built, because it was only building half the manifest file. So the timing between the cycle of acquiring that manifest file and our actually building the manifest file, they kind of smashed head on, and only half of a manifest file was actually being created. It still saw it as a complete XML structure, so it was able to read the content, but it was purging half of the data, and we had to come up with a way to do that. And the solution was actually very simple. I just directed the user to create a second file and then swap them out. And so instead of the latency that's involved in building the file using PHP, they then created the file kind of on the back end and then did a quick swap. And the swap was so quick that we never ran into that problem again. It also will check the headers for new copies of files as well. And this is what an XML-based manifest file would look like, and this is what it looks like for Cisco's product. Here I use Cyber Defense Contractors as an example. We don't currently use a CDN at the moment, merely because we haven't gotten to that point in our development of our online presence to require the need for a CDN, but we're actually in the process of doing that. Okay, in the backhaul. So look, over on the right, you have your programming studio. We have about 5 minutes left. We have your programming studio. That feeds the encoder. Okay, I mentioned that earlier. We're going to get back to that. And then that encoder splits that video stream with using ABR into 4 different bitrate streams. It feeds it to your origin server. Origin server feeds it into the CDN, which we are depicting as a cloud because, as we know, there's a lot of different moving parts, a lot of different components. And then that CDN delivers it to the video player on the user's desktop. CDN design. Okay, so when you're designing a CDN, some things you got to keep in mind. Place your surrogates at your largest sites if on the enterprise. Okay. Place them at your POPs if on the internet. Limit outbound streaming rate using the 30% rule. That's definitely something you want to do, and that's something we did by design. When I implemented this CDN, we already had a CDN implemented, and I had to reverse engineer how it was done originally, just to understand how a CDN works and how a CDN is meant to be designed. And what I found was that they use the 30% rule, and so that's something we incorporated into the new CDN. You want to use the tiered architecture, so a parent-child relationship, and you want no more than 3 tiers. You want to avoid a 4th tier if you can. If there's an outlier somewhere that you had to do it, I guess that's something you could approach without any real harm, but you want to kind of keep it to three tiers if possible. You have a primary and a secondary surrogate per subnet, and you always want them located close to one another, because if there's a failover, you don't want the failover to take place across the entire network. Then you'll have a large amount of data streams, video streams, crossing your entire network, and you do not want that to happen, because no network is designed to handle that, or no network is ideally suited to handle that. You have 4 redundant surrogates between 2 autonomous systems or tie points, and that allows for minimal traffic across autonomous system boundaries. Okay. CDN troubleshooting. The number 1 tool you're going to use is packet capture. Packet capture is your friend. That's what I used throughout the entire process. Looks like my dog has something to say about that, so we'll ignore that. But packet capture is your friend, and that's what you want to use. Splunk and Kibana make sense. I mean, they'll make sense of things for you, in the sense that it's statistics based. Know your HTTP response codes, because you're going to be dealing with them a great deal. And here are some lists of problems you might run into, problems that we ran into. Which surrogate should have provided specific content? So you might have to go back and look and see what the user's address was, and then look in the content routing file, the XML file, look it up and see which CDN surrogate should have provided that information or that content, and then go look in the logs and see if it actually did. So you might have a problem where you're misrouting sustained video traffic. Huge problem. If you're misrouting sustained video traffic, you could be routing gigabits, tens of gigabits per second of video, and not all networks are suited for 10 gigabits per second traffic. You might have content not replicating. The origin server and there might be communication failures between the origin server and the CDN. You might run into vulnerabilities. That's a common something common that you run into even before deploying your CDN. You might do a network vulnerability scan and come up with some vulnerabilities that you need to resolve before you deploy that CDN. There's also the API, phantom streams. Won't get into too much about that, but you might run into a situation where you think you're seeing streams, but you're not actually seeing streams. Statistics are reporting it, but it's not actually valid and true. We've got about 30 seconds left. A failure to send redirect, a full purge, server hardware failures, client CPU utilization is high, and content repeatedly replicating from the streamer to streamer. So some new technologies. LHLS, that's an Apple protocol, sub 2-second latency. It's backwards compatible, supports fragmented MP4 containers, and uses HTTP2 push. And then there's also low latency CMAF for dash, for MPEG dash, and that's sub 3-second latency, and it's easier as far as encoding goes. CDN security, just real quick, we should obviously talk about some security. You're going to have a distributed denial of service that you're going to have to contend with. You're going to want to put in a WAF, or a web application firewall. You're going to need access controls. You're going to need auditing and reporting. There's going to be zero-day malware. You're going to need to deal with DNS security, open SSL certificates on a per-tenant basis, and you're going to need isolation from attack. You're going to have encrypted web properties, and you're not going to want to store sensitive data on a CDN, especially a public CDN. Okay, and these are the attributions of some of the things we talked about today, and some of the resources you could go back to and look up. And that hit the 1 hour mark, so I'm going to conclude this presentation. Thank you all for visiting today, and I hope that I clarified what a CDN is and what a CDN does, and maybe you can take some of this information, and if you're planning on putting in a CDN or starting off in a CDN design, that some of this information will end up being useful to you. Or if you're just a user and you wanted to know how a CDN works, figure that's something you should know. Hopefully I provided that information to you today. Once again, thank you, and this is Rob Cluett signing off.